So you know that already. Let me flip through here. Two parts of my talk. First, I want to talk about how forecast monitor tourism with big data, okay? So I would introduce a few of my research. Second part, I want to talk about my idea of the challenges of big data. Challenges, future research for tourism big data, including the problems, how do we conquer the, overcome those problems. For the first one, I like to give you a behavioral model of tourism big data. Sometimes, as you know, big data approach many times is a bottom-up approach. So we have some data, we try to find patterns. We have to connect that data with behavior. So how do we start from a bottom-up approach with a top-down view? Because those data mean something, right? So that's one big challenge we have to think about. I will use several data sources: search data, website traffic data, social media data, and mobile data. I did some research in each of those areas. Then I will, okay, so before that, I will show you my website. This is my website with all my publications, my teaching team, my consulting work, my team. So I don't know if you have looked at my website. So you know what? Maybe I know that. So I actually checked out my my Google Analytics page. So my Google Analytics basically is a web statistics platform behind a website. I can see who's looking at my website, right? A company or business or researcher like me, a lot of power. So I can get to know you even before you step into the door. Okay, so if there, because it's always the customer will look at the website before pushes from you, then you can know the customer beforehand. So that gives you a lot of advantage. Okay, so let's take a big picture. This tracking is available, is possible, is because we have the developmental technology. In the past, we had the mainframe computers. You guys, you are too young to remember that, but when I was in college, I'm used to access a mainframe computer. All my classmates using one single computer. Then we have the, the connecting information. Now we're talking about the website structure, the client server structure. Then we have the social network era, maybe happening in the beginning of 21st century. So after 2010 or 2020, now it's the connection of intelligence. We call it the era of big data, or the Internet of Things. So that's like 4 different stages of development. And all these are possible because you heard about this already in the Moore's law, right? So every year, the computer chip is going to getting faster and faster. So according to Michael Moore, is that Michael Moore? According to Moore's law, every 18 months, you doubles your speed of computer, computer storage, or the pixels on your camera. So that the law determines we have more and more information, more and more data, and we can afford to use that technology in everyday life. Now that generates a lot of data, and that can mean a lot of power, intelligence for business, scientists. And even for people, we make the purchase, go visit the place. So you have this from a lot of volume, narrow down to smaller volume. And you know what? At each stage, we have some traces. Research stage, you have traces when people doing research on Google or visit your website. On the purchase stage, we have people buying stuff. In the US, you can buy actually credit card records to find out who's buying from this company to where. Visa or MasterCard, they are selling those kind of product. Of course, not individually. They sell the aggregate data. So I'm not sure Korea. I'm sure they have similar service. You know, the credit company can sell you the purchase volume. So we combine the graphing model and the purchase funnel theory. We come up with this. So the dot in the center represents the destination. The red dot. The black dots are the origins. You know, the size of the dots representing the population of a city. So of course you see the bigger the population, the closer to the city, the more people come to visit. However, as you can see, the volume slowly decreases because barriers. The barrier could be not enough marketing. Barrier could be no direct flight. The barrier could be the low income from the origin city. So the gravity model, actually, you can see the flow slowly diminish. You know what? The direct flight could be one factor here. If I want to visit Seoul, but it's so far away, and there's no, I have to switch airplane 3-4 times, that may give me some hesitation. The idea is you can run the regression like this line here. Imagine this line is the model. We can find out how fit they are. If there's a city right down here is compared to the model, they are not reached the level of visitation yet. We consider this city is underachiever, means they have a lot of potential, but they don't have a lot of people visit the place. Some cities are overachiever, means compared to the model, they have a lot more visitation to the place. We find out this the underachiever. For example, say Philadelphia may have supposedly have a lot of people visit Seoul, but in reality, maybe half of those people go to Seoul. So it means there's barriers there. So what's the barrier? Maybe it's no direct flight. So then we compare this city's, this underachiever with web traffic from that place. Just like, you know, Seoul Tourism Bureau may look at the visitation for their website from Philadelphia. They may see there's so many visitations to their website from Philadelphia, but not so many people coming. All right, so we have a result. Means we have a lot of potential from Philadelphia. With the model, we also find out whether or not you have direct flights does influence the number of people visiting the place. So basically, we run this regression. We find out the outlier. We look at the city, their web traffic. Then we find the potential market. And we can even figure out, look at the flight here, direct flight is significant. And we can even estimate the parameter. So we know if we have direct flight to this place, how many increase we have in the tourist volume. Sometimes when you show the results to my colleagues from in the US National Park Service, they don't believe in social media data because this level of accuracy is not enough. So we saw many research papers on the correlation. In reality, we need a precision instead of correlation. To make data really useful, we have to make sure it's maybe not 99.9% accurate, but have to be 99 or 98, 95% accurate. This level of correlation is not good enough. So if national park manager need to know precisely how many people come to my park, not like 10% error rate. So that's not enough. We did a similar study in Yellowstone National Park. We compared Twitter data, people tweeting in Yellowstone, with the actual visitation. Okay, so those are the places people tweeting inside Yellowstone National Park. This is a monthly visitation. The blue line means tweets. The yellow line means the official statistics. Again, you have to see some correlation. However, like in the winter, there's more tweets about Yellowstone than the actual visitation. Okay? And also from your Twitter profile page, actually you can tell this person's gender and age through machine learning, because it's easy to run some Google Vision to figure out this person's photo is a male or female. How old is him, he, or she, is she or he, right? I did this on myself. It's pretty accurate. I put my picture through Google Vision, tell me I'm a male, probably Asian, not 95% Asian, of course, they see me a little bit younger than I actually is, but it's pretty accurate. So later we did a study. We combined multiple data sources, big data sources to forecast. We use search engine query data, website traffic, weather information, even events. Events means if you have a festival, we predict there will be increase in visitation. We found out only one data source is very useful, website traffic. Other data, it's kind of highly correlated with web traffic. So make them non-useful, useless. So here's my take. Big data forecasting has an upper bound. Okay, you can only do so much accuracy. You cannot increase anymore by including more data sources. There's a limitation there because you have like highly correlated, they are all highly correlated. Now that's a problem. And when you talk to hotel managers, and they will tell you, well, we're using linear regression, or we're using just seasonal forecasting. If work data is 95% accurate, we are happy. They don't need 100% accuracy. We cannot never achieve 100% accuracy. And good enough forecasting is good enough in real life, right? I mean, if I know 5% for sure, we 5% error rates, how many people visit my hotel, then I know how many people I need to hire to clean the hotel, to serve people. I don't need a 99% accuracy. Good enough forecasting is good enough. I mean, data is data, right? Sometimes, how do we move from data to knowledge? That means we have to correlate different sources together. We have to combine big data with, say, small data, with survey research, even with qualitative data to make sense of the data. So that's knowledge. Now, from knowledge to insight, we need to move one step further by doing some experiment, for example, to confirm our hypothesis. So that's why, Amazon or TripAdvisor, those online travel agencies have a lot of advantages because they can do those testing in real time. Amazon conducts 300 experiments every day. Even without you realize that. You are using Amazon, you are being tested. They switch this picture with that one, switch different color about this picture to test which picture will make you buy more. So that's insight. So from knowledge to insight, we really need to do experiment. But that's hard to do, right? We had to work with online travel agency, maybe tourism bureaus to allow us to do experiment on the website. But that's truly valuable. So there's a story. This is a paper published in Science in 1854. Okay? John Snow, he's a doctor. Back then, there's a outbreak of cholera in London. A lot of people died, and people don't know why. So people think this is like an evil spirit going on. John Snow, this doctor, he just simply map out all the places of the patient on the map. Those dots lead to a well in London. So he figured out, okay, the origin of that disease is that well. Because back then, people have no idea about this, bacteria, or virus. They have no idea about those, bacteria, virus. Scientific knowledge is not there yet. But by simply mapping out all the locations of the patient, they figure out the origin of that disease is that well. So they shut down the well, they fill it up, nobody uses that well, the disease decreased.